वेलकम बैक टू ऑडियो वीडियो। चैप्टर नंबर 3 स्टार्ट कर रहे हैं। क्वांटाइजेशन ऑफ चार्ज, light and energy. The idea that all matter is composed of tiny particles or atoms dates to the speculation of the Greek philosopher and his teachers Leucippus in about 450 BC. However, little attempt was made to correlate such experiences with observations of the physics world until the 17th century. Pierre Gassendi in the 9th-17th century and Robert Hooke, somewhat later, attempted to explain state of the matter was transitions between them with the model of tiny, incredible solid objects flying in all directions, but it can be Avogadro hypothesis advanced in 1811. In all gases, arguably the temperature contains the same number of molecules per unit volumes that led to great success in the elaboration of chemical reactions and to the development of kinetic theory in about 1900. Avogadro hypothesis made possible quantitative understanding the malleable properties of many metals which led to general the molecular theory of matter. This matter is non-continuous as it appears, but it quantized of the microscopic scale. Scientists of the day understood that the small size of the atoms prevented the distances of the matter from being readily observable. In this chapter, we will study how these additional great quantizations discoveries were made. Electric charge, light energy, and energy of oscillating mechanical systems. The quantization of electrical charge were not particularly surprising. The scientists in 1900 it was quite analogous to the quantization of mass. However, the quantization of light energy and mechanical energy, which are the central importance in modern physics, were revolutionary ideas. Quantization of electrical charge. Early measurement of E and E over M, the first estimates of the order of the magnitude of the electric charge following that atoms were obtained from the Faraday's law, the work of the mechanical Faraday in the early of mid-18th century stand out seven. Even today from its visual experiments, intuitions and through the story of the self-articulated blacksmith Solomon Rosda enlightened by book builders appearances to become the director of the distribution Royal Institution of the London and the foremost experimental investigation of this time is a fascinating world. One aspect of his work concerned of the study of the conduction of electricity in weakly and non-operating solutions. His discovery that the same quantity of electricity of local the Funday equal about 96,500. He always decomposes and grab illuminate that it is Avogadro numbers of non-violent ion leads to the resonant conclusion that each non-violent ions carries the same electric charge. Equation number 3 was called Faraday's law of electrolysis, where F was rarely variable, neither La or nor could be experimentally determined in the time Faraday was aware of. This but does not determine either quantity, even so it is seemed logical expect that the electric charge, like matter, was not continuous, but it considered how the particle of the kinetic theory is to compare the value of E from equations However, a direct measurement of the value of E had the weight intelligent experiments are conducted by R.A. Malikian the third of the century later. Meanwhile, Peter Zemal in 1896 obtained the first evidence for the existence of the atomic particles with a specific charge-to-mass ratio by looking at the change in the discrete spectral lines emitted by the atoms when they were placed in the strong magnetic field. He discovered that the individual spectral lines split into three very closely spaced lines of slight different frequencies when the atoms were explains spiritual light energy atoms when they were placed in the strong magnetic field. He discovered that the individual spectral lines split into the three very closely spaced lines of slightly different frequencies when atoms were placed in the magnetic field. This phenomenon is called Zeeman effect and will discover the further in chapter 7. Classical electromagnetic theory relates the slight difference in the frequencies of adjacent lines to the charge or the mass ratio of the oscillation change, producing the light from these momentums of spacing. Zeeman calculated Q over M to be about 1.6 multiply 11 10 की power 11 coulomb over kilograms, which compare the favorably with the precisely accepted the value drop from the polarization of the spectral lines. Zeeman calculated that the oscillating particles were negatively charged. Discover the electron Thomas experiment. This year, following Zeeman's work, J. Thomas measured the Q over a value of the called cathode rays were produced electrical discharge gases and pointed out that if they were changed the Faraday's change E and determines strongly the mid weight was only a small fraction of the mass of the hydrogen atoms 2 years earlier. Japanese had collocated cathode rays on electrometer found in them to carry a negative electric charge. This was the measurement of Q or M for cathode rays. Thomas had in fact discovered the electrons. The direct measurement of E or M of electrons by J. Thomas in 1897, a little over the century ago, can be justly considered to mark the beginning of the understanding of atomic structure. Measurement of E or M when a uniform magnetic field of strength B is established perpendicular to the direction of the motion of the charged particles, the particle moves in a circular path. The radius r of the path can be obtained from the Newton's second law by the setting the magnetic force will u be equal to the mass m times in centripetal acceleration u square over r, where u is the speed of particles. So q u b over m u square over r equal or r equal mu और क्यू बी एंड क्यू और एम इक्वल टू यू और आर बी। आज की वीडियो तक यही काफ़ी है। आखिर में आपसे एक बार फिर रिक्वेस्ट, इस तरह के मज़ीद इंफॉर्मेटिव वीडियो देखने के लिए हमारे चैनल को सब्सक्राइब करना मत भूलिएगा। मिलते हैं नेक्स्ट वीडियो में, तब तक अपना ख्याल रखिएगा।